So first of all, my name is Mark Phillip, and I'm an application engineer with Studica Incorporated. And a quick bit about Studica: we're a software and hardware reseller, and we primarily deal with schools, mostly in North America. So we do a lot of K through 12 and college, and basically help people get software and hardware. So we've been doing this for a little over 30 years, and today we're going to be looking at a product from fischertechnik called the Robotic Sensor Station IoT, I think is the official name of it. And so we're going to take a look at that, and we're also going to take a look at IoT in general, and we'll talk about what is IoT and some of the trends currently as far as the IoT market's concerned and where it's going in the future. So we'll have some statistics and some kind of data analysis there. And we'll break down what the product has to offer, and hopefully you find it interesting. Shouldn't take more than 30-40 minutes. So yeah, if you need to contact me for any reason, my information is markp@studica.com, and you can see our website, www.studica.com. So I want to just start off with what is IoT. I know if you're on the webinar, you're probably pretty familiar, but just for clarity's sake, We'll use the Wikipedia definition, which says the Internet of Things is a network of physical devices, vehicles, home appliances, other items embedded with electronics, software, sensors, actuators, and connectivity, which enables these things to connect, collect, and exchange data, which is quite a mouthful. I generally just define it as devices that have a way of connecting with each other and sharing data for some purpose, which is, I think, a little simpler, less of a mouthful. And some examples of this would be, for instance, I think a good example of this in our current lives are wearables such as pedometers. So things like your Fitbit, for instance, is a very simple example of IoT, because the Fitbit itself is just a hardware device that has sensors in it. So you wear it on your wrist, and it's running some kind of algorithm that's trying to track your velocity and your positional changes, as well as like the rotation of your arm, to determine how many steps you've walked. And it shares that data through, I think, Bluetooth to your phone, which then integrates with some kind of application, so some kind of software that takes that data and does something with it, whether that's graphing that data out or sending you a notification that you haven't walked enough. That's a very simple example of IoT. And then that extends into larger scale things like the smart home, for instance, where all of your appliances talk to each other, or Alexa turns on your home security system for you. And then the idea of connected cars, where we might have automated vehicles in the future that are all communicating with different, hubs and different sensors to basically figure out routing and make themselves more efficient. So that's kind of what IoT is. And let's look at where this technology is kind of going. So this data I found from a statistics firm called Statista that basically looked at IoT connected device installed worldwide from 2015 to 2025. This graph is in the billions. And we basically see in 2015 we had about 15 billion devices. And they're projecting by 2025 roughly 75 billion devices. That's pretty drastic in a 10-year period, and you can see this curve is starting to look a little bit exponential as we go on. Basically, the whole point here is that there's going to be a huge increase in IoT devices in the next 10 years, and this is going to necessitate skilled specialists to deal with this technology. And so a lot of the focus of this presentation is going to be like, how do we train people with this technology, get them used to this so that they're prepared for that future. Now, who's using IoT? A lot of people might think it's consumers, because that's generally what we see in our day-to-day lives, but that's actually not true. It's most heavily in business and manufacturing and healthcare. It is, however, becoming a more regular thing for consumers, but with smartphones enabling capabilities with all sorts of devices, smart cars, and even things like Alexa. However, the largest adopters are still in business and manufacturing, and then healthcare. And this distribution is expected to continue into 2025. Pretty much everybody who's analyzed this has all said the same thing about this topic. And this infographic here comes from Intel, who has done a lot of research on IoT because they would be one of the big players in that market. Now, what countries are actually using IoT? I mean, it's all over the world, but some countries are adopting it more than others. The clear people in front here are North America and Europe. However, there is a presence in South America, the Asia Pacific region, the Middle East, and Africa. Probably most interesting is that each region is kind of adopting it in different sectors. So the one I always look at is Asia Pacific is actually they've adopted more smart agriculture than, say, Europe has. So clearly we're seeing certain regions have more of a need for certain things than other regions. But the main thing here is that everybody's adopting this. This is a technology that's worldwide, and it's going to become more pervasive as we go on. Now, on the economic side of things, this chart's showing us the size of the Internet of Things market worldwide in 2014, 2020 by industry in the billions of dollars. Now, I want to point out that this is like total spending over time. This isn't within a year people are spending $3 trillion on IoT. It's pretty much like since they've started measuring this data, we've spent $3 trillion as of 2014. However, Statista is expecting a spending of roughly $9 trillion by 2020, which is very aggressive. And some people like Intel actually are more conservative. They're looking at $6.2 trillion of spending by 2025. So the main thing here is, regardless of which number you're looking at, there's a lot of money that's going to be blowing up in this realm in the coming years, which means a lot of job opportunities, a lot of need for specialists, and a lot of interesting new technology where there's going to be a lot of new research. So a lot of demand here, and it's affecting almost every industry to some extent, as we see in the graph. Now, further, how does this money like break down? We want to kind of look at, of all this money, how is this being split up? So this graph is kind of showing us that, and this graph assumes the Intel figure of about $6 trillion. And what we see is that hardware is actually making up the biggest portion. So, you know, that's going to be all the different devices you're going to be working with. Like, right, your Fitbit has a bunch of hardware in it. So there's going to be people who are manufacturing that and designing it. Connectivity is going to be a big one. So that's going to be things like your networking infrastructure, your 5G networks. IT installation services is also big. So that's a lot more of kind of maintenance and care and implementing these things. And then software is 16% of it. And then anything as a service, that's what XaaS is kind of the cloud side of it, or just providing kind of running cost services for some of these IoT devices. So the whole point here is all of these fields are involved with skilled specialists, right? Hardware is going to have electrical engineers, computer engineers. Connectivity will have networking engineers and people to handle that infrastructure. IT installation services, that's going to be your IT administrators and people like that. Software is your computer scientists, software engineers. All these fields require at least some level of education or at least certifications, maybe trade school, right? So these are all highly paid fields, and there's going to be a huge demand for this. There's going to be a huge pool that needs to be filled with people who can handle this influx of new technology. So that brings us kind of why is learning IoT important? Hopefully it's pretty self-explanatory based on what I just presented there. There's a lot of highly paid jobs. There's going to be a lot of opportunity. This is where the world's heading as far as technology, and it's going to be something that's an everyday part of life. So students who are in school now can really start preparing for this so that they're in a great position when they graduate to really jump into this field. And additionally, beyond just the money aspect, like IoT is enabling a whole lot of interesting new technology where there's huge opportunities to make an impact on research and just kind of the exploration of that technology. So it's a big deal, and we think that helping schools try and implement something to learn IoT is important. So that pretty much brings us to the fischertechnik robotic sensor station. And so we'll pretty much take a look at this and kind of some of the modules you can do with it and how it serves as an introduction to this world of IoT. And we have two different models, which we'll discuss more later, basically the differences between what parts come with the kit. But the idea is to really introduce students to data logging, the idea of a smart home, and which consequently is pretty much a part of the Internet of Things. So getting them all familiar with these topics is a big deal. So it starts off with basically a discussion of the different components of the sensor station. So people who maybe have never used fischertechnik before, they're going to want to kind of have an understanding of how do we work with these parts and how do we put them together. What are these different parts called? And it will talk about the actuators, sensors, the software you use to control it, which is RoboPro, and then it will talk about this TXT controller and how you can use this to wire electronics and then program for it. And you'll also get introductions to the RoboPro software and their graphical programming, which is kind of like you see here. This sort of flow chart is basically like a logic chart that this is what RoboPro looks like. You tell it to do something, it goes to the next thing, and you can create loops and basically create, program structure out of it. So the first thing that students will do with this kit is create a lighting model. And basically what this will do is, as it becomes darker outside, the lights here turn on. And this will have students basically work with a photoresistor and control which lights turn on based on the level of ambient brightness. So it's a good activity to really introduce students to become familiar with the TXT controller and kind of just the general fischertechnik workflow. And so beyond the first lab, they'll also go into setting threshold values of brightness from the photoresistor. So basically detecting, what's the resistance on the photoresistor, and if it reaches a certain level, we're going to turn on this light, then that light if it goes higher, then that light if it goes higher, for instance. So this will involve a very simple program that will allow you to kind of do if statement logic, if you will. And after that, students will work on a noise sensor, and basically students will utilize a sensor that's built into the circuit board of this USB microphone that's right here, the camera, which is this device right here. There's a microphone built into it that's going to connect USB to the controller, and then students will be able to grab that data, determine what the decibel level is, and turn on different colored lights to basically determine how loud the sound is that's coming into the microphone. So what's interesting with this bit is that it will introduce students to the idea of a subroutine, which is sort of like a function in traditional programming, a function or a method, for instance. And whoops, not mean to do that. But we'll go ahead and look here at a very quick time lapse I did of putting together this model. You'll notice there's not a whole lot of parts. It's very simple to build, and the instructions that come with it are very easy to read, very clear. I didn't really have any issues putting this together from the instructions. You can't see it here on the screen. I'm referencing it off screen. But yeah, so you just build the whole thing. You connect the camera, which is what I'm doing right now. And then you do the wiring, and the wiring diagrams are also included in the manual. So you can figure out what inputs you have to connect to on the TXT controller. And then this is it in action. I don't have sound, but I'm basically just talking to it, and these lights are changing color as I speak. So it's green when it's quieter, it's yellow when it's in between quiet and loud, and then red when I'm really loud. So this is a very basic module from this kit that will help introduce students to more elements of dealing with like audio, for instance, and then building subroutines within fischertechnik, which will be more important as you go into the later labs. So on here we have a couple screenshots of the programming involved, and I don't expect people to know what this means necessarily, but what we see on the left is the actual subroutine. So this is where you're actually wiring your inputs to check against the microphone levels, and then basically, depending on which gate gets activated, you send a certain output, and then your function, your subroutine goes here. This big green block on the right screenshot is taking in the microphone input and then a constant value that we're checking the decibel levels against, and then this is going to run it's going to run this and send one of these three outputs, which comes out here to activate one of those three lights. So yeah, it's an interesting way to kind of get students used to the logic of programming, as well as kind of general like circuitry, right? This is very similar to kind of lower level what you would look at on like hardware. From there, we're gonna replace the a USB camera with an environmental sensor, which is this green rectangle here. This is actually a new fischertechnik component, and the idea here is that this will enable robotic models to measure gas, atmospheric pressure, humidity, and air temperature. So students are going to incorporate a special block in their programming that will deal with an initialization and a get block to work with this. And there's going to be 3 different programming projects addressed by this model. And so the first one, they're going to create a frost monitor. And with the frost monitor, the ambient temperature is basically monitored using the wellness sensor. And if the temperature falls below 3 degrees Celsius, the warning lamp comes on, the red light will turn on, basically letting you know that there's frost. It's probably going off all the time in the Midwest right now. So in the second project, the students will do a mold monitor where you're going to measure the humidity of the room. And if the humidity is like 80% or higher, you're going to turn on the warning light. And then the third project, students will do an air quality monitor. So they're going to basically program the models so that the lights are illuminated differently to indicate different levels of air quality. So if we're in good air, we're going to get green, bad air is going to be red, for instance. So after that, students will be able to work on a model of a stationary camera that's going to also have an environmental sensor. And this will basically involve programming this to act like a motion sensor, which will turn on an acoustic and visual alarm. So the TXT controller can send out a sound bite, so it will send an alarm signal, and then the light here, the red light, will turn on as well if it detects motion. And then the second exercise here is going to be much more about data logging. So it's going to look at the values registered by the brightness sensor, or the photoresistor, I should say. And then that data is displayed graphically on an oscilloscope monitor in RoboPro, like we see here on the left. And then the third exercise from this model will involve logging the values into a spreadsheet program. So basically, we want to be able to display the data on a beam diagram. And then the fourth exercise will combine the last two, where the data is both displayed on the oscilloscope and at the same time the values are saved to a CSV file so we can look at them on a spreadsheet. And I already clicked forward. That's confusing. So then the last experiment with this model will use this flower vase experiment. And the idea here is that we place this station in front of this flower vase, and then the student creates a program that's going to measure the temperature, humidity, atmospheric pressure, air quality, and brightness in the room. And then every 12 hours, we log that data into a CSV file, and every day a photo is taken to basically monitor the growth of the plant. And then over time, you can kind of look at this data, look at the growth of the plant. So this is a bit more of a long-term lab that you would do with this particular model. And then from there, students will be able to make a barometer and program it so that the pointer on the model will point to a weather symbol, such as sun, cloud, rain, lightning, whatever, that corresponds to the current atmospheric pressure, depending on what's measured by the device. So that one's pretty straightforward. And then the final model kind of combines all of this stuff together. And what it will do is the students will build this set that is the complete sensor station that has a movable camera. The model is going to utilize various forms of data transmission. So we'll look at connecting via USB, using an access point on wireless, and then also using the cloud system. So in the first programming project for this model, we'll look at making a rotating surveillance camera, which we see here. This big old this big thing right here is the rotating platform for the camera. And we'll be able to view the results on a computer using the RoboPro software. And then students will learn how to connect the TXT controller to a PC using Wi-Fi so that they can make this more portable around the house. They could bring it, to the backyard or something and have the camera monitor what's going on. And then the second project will be an expansion on that, where the camera's controlled, but the environmental data is also displayed on an oscilloscope. So we'll do data logging here, and we'll also implement an alarm so that if the camera detects motion, this light will turn on. Whoops. And then the next project is going to involve connecting the sensor station to the cloud. So Fischertechnik has their own cloud site where you can basically connect your, oh man, my mouse wheel keeps scrolling, where your device can basically connect to their server, and then you can view all your data through their website. So that will kind of help facilitate this idea of, you know, being able to access your data from anywhere, even if you're not at home, for instance. And yeah, this is what that looks like, and I'll actually be showing a demo of this in a second here. So let me go ahead and pop that open. So I'm going to first look at RoboPro, and this is the RoboPro program, and this probably looks really intimidating, but I want to emphasize that this is pretty much the last project you would do with the kit. So you would be going through the other projects, basically learning how to get to this point. So by the time you get here, it wouldn't be as intimidating. But I can see the panel here, which is going to show me my data, show me all my readings, and then my camera will show up here. And then my camera section here will show me the motion activation portion of it. So let me go ahead and start this. And that sound you're hearing right now is basically the device centering itself. It's supposed to be centering itself. Something just happened to my device. I don't know what. Sorry, I'm trying to... This was just working right before the webinar. Well, whatever the case, I can't, for some reason, I think one of my cables came out. I'll have to fix it later, but the platform generally rotates as you saw at the beginning. I'm not able to control it at the moment because I think something came loose, but usually you can control this with these options here to move it right, left, pan it up and down. You can also track your data here. So we have like temperature reading in Celsius, and then humidity. And then we get, I believe this is atmospheric pressure. I could be wrong. This is the brightness. So this is the photoresistor. And if I kind of cover that with my hand, we can see it jumping up and down as I limit the light hitting it. So it's monitoring all this data. And we also can turn the alarm on so that if we get motion, a red light starts flashing. You can't see the red light on your end, but you can see how the alarm triggers when my hand goes in front of it here. And we can actually see that on the camera portion. We can see where, when it flashes green, that means it's detecting some kind of motion. And I wish this thing would turn. I'll have to fix that later. So yeah, this is pretty much the data you're getting out of it. You can also see your motor 1 and motor 2 positions that are turning the base around here. But like I said, since I think something came loose, it's not working for me at the moment. But normally you would be able to see your motor data here as you turn it around. So that's all the data that we have. And then if we want to see that on the actual site, we can come on to the Fischertechnik site, and then let me run the program. So in this mode, we run the program locally on the TXT controller, and then I see what happened. Whoops. There we go. Okay. One of my cables got stuck in one of my gears. And then what it's doing now is it's running locally on the TXT controller, and now it's going to basically be sending the data here to the cloud site. Now I'm going to refresh the page. And sometimes it takes a few seconds to get here because I think Fischertechnik servers are in Europe, so my connection's got to go across the Atlantic. There we go. So we have my camera access here, and I can control it with these options here, and you can hear it rotating, and you can see it moving up and down. It's a little laggy, like I said. It's traveling quite a distance, and my internet's been a little unreliable today. And then we have other data here, and I can also I can also like take a picture, and then it will save that in the gallery over here, and I could download that picture if I wanted to. There's also the brightness here that's measured. So again, if I put my hand over the sensor, we'll see the resistance drop. I can also change how this looks. So I could look at a curve instead of just a single value. So I can measure the brightness over time. I can also download this as a CSV file and then open that in Excel. So in the CSV file, I get like my date, my time, and my brightness all laid out here. And what's nice with it being in a CSV file is if you want to do any sort of like data analysis using Python, for instance, like programming languages, CSV files are highly compatible with that because it's all just separated by semicolons, so you can easily organize your data. I'm going to not save that. Additionally, if I scroll down, I can look at the temperature. And just like above, I can look at a curve for the temperature, or I can look at just a single value. And I can also download the CSV file that shows me the temperature over time. I can also see the air pressure, and just like everything else, I can do a curve, I can do a single value. And then air humidity, same thing, curve and single value. And all this data can be downloaded as CSV files, and I can also customize my UI here. So if I want to like drag and drop humidity there, or like move certain things around, I can do that. What's also cool with this is that since it's on the cloud, this is actually something that you can access from your phone. So you could come to this website and take a look at it on your phone. So the idea behind the cloud situation is to basically reinforce this idea of I can put this device anywhere, and as long as it has a connection to the internet, it should be able to hit this server, and I should be able to access that server from anywhere on the web. Well, from the web, I should say. So, you know, you can bring it up on your phone and bring it up on your tablet, or bring it up on your computer at work when you have the device at home and things like that. So yeah, that's kind of the overview of the cloud setup. And then let me close this out. And let me stop the program, and let's continue on here. So kind of in closing, we just want to look at the actual pricing here. So there's two different kits, and this 544625 kit, this one actually requires the RoboPro software, the robotics TXT controller, and either the AccuSet or PowerSet. So basically this one, it's cheaper, but it doesn't come with some of these things that you need. So if you've never used fischertechnik, you would definitely need to get this one. If you've used fischertechnik and you have these things, then you should be able to just get by getting this kit. However, if you need these items, any of these items, you're going to want to get the complete set, which is $679, includes all this stuff. So those are kind of the two options, and you can see them on our website at studica.com. And at that point, I'll open it up for questions. If you do have questions, please use the chat feature, because I have everybody muted so I don't get feedback. And we'll do our best to answer those questions. And in the meantime, while I wait for any questions to come in, I just want to point out some more contact information. So you can see what we have on our website, studica.com, and you can just look for fischertechnik in our search bar, and you should find all of our fischertechnik stuff. We are, I believe we're the exclusive distributor of fischertechnik in the United States. So we have all sorts of different fischertechnik stuff on our site, beyond just the sensor station as well. You can also email us, sales@studica.com. So if you had sales questions or questions about pricing or anything like that, you can talk to somebody about that directly. I generally don't have answers for sales questions. I'm more of a technical person. You can also call us at 888-561-7521. We're open Monday through Friday, 9 to 5 p.m. Eastern Standard Time, to talk to somebody if you need to. And I will point out that we will be sending a follow-up email that's going to have some extra information, as well as a recording of this webinar. If you need to reference it or give that recording to anybody, feel free to do so. So yeah, if there's any questions, I'll wait here for like another 30 seconds or something, see if I get anything. I believe viewer 11 is Christy. That's my coworker, our marketing director, so she'll be following up everybody with an email. All right, well, not getting questions, so I'll go and close it out. I want to thank everybody for coming, and I hope you all have a good day and a good rest of the week. Thank you.